We're going to explore the simple functionality of an electric motor. And so the first things first, I've drawn out this image that shows an electric motor that I built, and it consists of a voltage source or battery, two green wires, a coil of wire wrapped around X number of times, and a magnet below the coil of wire that produces what we're going to pretend to be a uniform magnetic field. And so this is the motor that I've built, and as you can see, it's turning the coil. And so we're going to learn how this happens. Okay, so first we examine this first image. And so we see that as the magnetic field flows through the coil, there's also a current flowing through the coil, as produced by the voltage source, the battery. And so using the right-hand rule, we can determine that based on the current flowing into the page, the magnetic force pointing up, we know that the force is going to go to the right at the top of the coil, and at the bottom of the coil we can do the same thing to determine that the force is going to the left. And so this difference is going to create a torque in the coil. And in the next two images you can see that as that happens, the coil is going to turn. At some point the forces will cancel out, but because the coil is trying to overcompensate for that change in movement, it's going to keep going, and the coil is going to keep turning as long as current is flowing through the coil. And so in the last image, you can see how this is actually affected by a mathematical relationship of torque to the current multiplied by the area of the coil inside the coil, the magnetic field that goes through the coil, and sine of theta, which is just the angle between the magnetic field and the area.